Today I will discuss about the Zener diode as AC voltage regulator and breaker at low voltage. Last time I have discussed about what is the meaning of the Zener diode. In last lecture I have discussed what is the meaning of Zener diode and how it act as a voltage regulator for DC and breaker at low voltage. But now I will discuss it for AC voltage. So if you are interested, if you are unfamiliar with the Zener diode, and you are interested how it work to regulate the DC voltage, uh, you must visit my last lecture. The link is given at the description. Okay, so now let's start the Zener diode as a AC voltage regulator. AC mean alternative current voltage regulator and breaker at low voltage. As I have already discussed in the previous lecture, Zener diode always use uh, to regulate the voltage, high voltage, and it also used for regulate the high voltage. So if I connected it in the uh, parallel to load resistance mean the appliance resistance of the appliance. Okay, if I connect it parallel to the load resistance, then it will be work as a voltage regulator. Okay, for to supply this in a constant voltage to voltage regulator for high voltage. Okay, so if you are but if for AC in for DC we have use one Zener diode parallel to the load resistance, but for AC I have to connect two diode. Okay, so as I have described in the previous lecture for DC, firstly I have to apply the resistance so that the current will come into the in the limit of diode. Okay, so we can save the diode from the uh, damage. Okay, for this purpose, we now that for this purpose, I will use two Zener diodes of same kind. Mean okay, input is AC voltage. So two diode of the same kind is connected in such a way that uh, both n both n part of the diode must be faced to each other. You may connect in such a way, though both P part may be facing, you may connect in such a way that both P part may be facing each other. But for this time, I'm using uh, 2N are facing, N part of the two Zener diode are facing to each other. So, they will be connected in this way. Now, the parallel to the load resistance. Uh, okay, this is RL mean load resistance. So in this way, this will be regulate high voltage. So it will be used as a to regulate the high voltage. Okay, what will be happen? For example, we must use these both diodes must be of the same kind. So they have the same Zener voltage value. I mean, I may say that this is a VZ. So this will be also a VZ. If they both have, for example, if these have the if the VZ has limit uh, you may say that is 5 to 5.5 volt. Okay, Both diode are the same kinds, having the same limit. Okay, so both diode value is also a same. So what will be happen? Okay, when there will be a, as last, according to last lecture, there will be a different when the so as we know that we must draw the as example, if we know that alternative, if this is a, let's suppose this is a, let's suppose this is AC wave, and these are for time 1, T2, T3, T4. Okay, these, let's suppose these are the input AC wave for different time. Okay, so this is input AC wave. Uh, you may, I think, trying it here. I mention it here. Okay. Okay. So for input AC wave, if I draw the input AC wave for different time, for example, for different time, for example, if I considering the different time, uh, this is for time pulse. Okay, this time input pulse, mm, equivalent circuit. I will draw the equivalent circuit here. Uh, so for time t1, okay, input pulse has we from observe from the diagram. The input pulse will be like this. This is t1. Okay, for time t1, this is the input wave. What will be the equivalent circuit? Because for this purpose, for this time, mm, yes, for t1, uh, we will be greater than 0. We will be greater than 0. So if V is greater than 0, then the all current will be passed through the resistance, and then a diode, this, if I say that this is D1, this is D2. So the because the P will be more positive, so and N is a negative diode. D1 will behave like a forward bias, but diode diode 2 will be this diode D1 will be forward bias, so that will behave like a short circuit, but diode 2 will be uh, behave like a open circuit, and so no current will be flowed from this. Okay, and at output, what will be what so all the voltage will be drop across the load resistance or L. This is true for, but V is less than Vz. When the voltage positive but less than Vz. Uh, but if V is greater than 0, because the but V is greater than Vz, if there is a extra voltage, okay, if V is greater than uh, uh, our voltage limit, then diode D2 will behave like uh, as I have already explained, that will diode this diode this diode and this diode will be activate, okay, and this will be come into the breakage voltage limit, or at it will be entered into the Zener diode, sorry, Zener voltage limit, okay, and the current, saturated current will be passed through it, and so it will act like a uh, you may say that the maximum current will be uh, pass uh, pass from this diode to in such a way that it regulate uh, the extra voltage. Okay, so it will behave like a battery. Okay, you may say that the equivalent circuit will be, I may draw it, then you will understand. If you don't understand, you may visit my first lecture about the Zener diode. So what will be happen, this uh, D1 behave like a, this is D1 will be the short circuit, and D2 will be not a short circuit, but it will uh, behave like a voltage V, whose voltage is equivalent to equal to Vz. Okay, so at output you will get the load. Uh, there will be a load resistance. All will be in first case current will pass through this. So input wave will be same as the output wave. Okay. So this will be your for T1. This will be equivalent circuit. Okay. Okay. What will be the outputs? Okay. I must for this outward. Sorry. For so for this V out or load output will be equal to V in, because all voltage is dropping across the load resistance. So V out will be equal to V in. But for this case, V out will be equal to Vz. So if the that will be equal to voltage will not cross the 5.5 or 5.5 limit. Okay, so output will be equal to around about 5 voltage to 5.5 volt. This is for the time for T1. For 42, what will be happen if I draw input wave? If I say that this was a input wave for T1, but now actually this time is T2. We are considering the 42. 42, that will be T2. 42, the equivalent circuit diagram for when the voltage is negative, what will be happen? Now you may see that because negative, so end part of so so far if there is a negative input wave is AC wave AC wave part is negative. For input wave is a negative, then for that end part of the diode become a more negative, and P part will become a positive, mean more positive as compared to N part. So this diode will become a forward bias, and this will become a reverse bias, and it will act like a Zener diode. So if the voltage is low, then it will be diode D1 will be non-active, uh, and it will behave like an open circuit. Okay, but as it voltage exceeded to voltage limit at negative side, then it will be activate, and it will behave like a battery. Okay, so in that case the equivalent circuit will be like this. Sorry. In this case, D1 behave like a open, but D2 will behave like a forward bias. Okay, this region is D1 is as a forward bias, but D2 will behave like a open. Okay, and this will be load resistance. Okay, and so all current will be passed through. Okay. So even in the case of the negative, for if the voltage is negative, okay, I must write here. If V is negative is less than zero, but V is because now D1 will behave like a forward wise, okay, negative because only sorry, D2 will behave like which is connected a reverse wise will become a forward wise, and which is connected forward wise that will become a reverse wise. So D1 will become will behave like so, but V magnitude is but V is so V magnitude is less than Vz. Okay, then that will behave like this, and but when V is greater than so V is less than 0, but V magnitude is greater than Vz at negative side, then diode 2 will act like a diode 2 will act like a negative negative voltage, okay, battery, okay, because nahin, diode 1 that is diode 2 nahin, diode 1, okay, this is I written wrongly, this is diode 1, this is diode 2. So diode 1 will be act like as a reverse wise and will behave like a open for case 1 when V magnitude is less than Vz. Why? Because the P become a negative and N will become a, so that will behave open, that diode 1 will behave like a reverse wise, and so this will be there will be on this will behave like a open, okay, and D2 will be because negative part become a more negative, that will become a forward wise, and so it will behave like a short circuit for the case 1, okay, when V is less than Vz, but V magnitude is less than Vz, but when V magnitude is greater than Vz, then cross the limit, then diode D1 will be, which is behaving as a reverse bias, will be entered into the uh, saturated current region, where, or you may say that at Zener diode D1 region, where Zener diode region D1 will be entered into Zener diode region. So voltage will remain constant. I mean, it act like a battery. Okay, I mean, it will not allow to exceed the voltage. So that will be the because it is a negative, so the negative current is, so that will be act like a negative battery. Okay, and voltage will be equal to V will be equal to Vz. That may that is round about the that is equal to 5. So diode the 2 will be act as a forward wise, and so all the current will pass through the load. So negative in case negative voltage in reverse direction, and so voltage will be remain the same as the battery, because the input voltage will be absorbed dropped across the D2. Okay, sorry, D1. This is actually the D1. Okay, so according to first case, the same V out will be V in, which is a negative. Okay, and V in will be equal to, because it is V out will be negative Vz minus 5 to 5 4. Okay, so this is the equivalent circuit diagram. So this is for so how in this way the this this circuit diagram of Zener diode will regulate output voltage for high voltage. Okay, but if the voltage are uh, if I interested that there must be a circuit breaker to break the circuit at low voltage to save so that our appliance may work uh, smoothly. In the either case, if the voltage are very high, then it will be uh, the constant voltage will be supplied to the output, and if the voltage are very low, then the circuit will break and no current must be passed through the load. For that case, I have to join diode uh, two diode in series, as in the case of DC voltage. And in DC voltage, we join single voltage, single Zener diode. But in the case of AC wave, we have to consider two diodes, not a single diode. Yeah, it is true for the high voltage, to regulate high voltage. Two Zener diode uh, will be connected in parallel to load resistance. Similarly, for breaking the low voltage, we have to connect So for regulate high voltage as as well as break the circuit, break the uh, current supply for low voltage. For that case, the circuit diagram will be as in the case of the previous. Resistance R for regulate and this was a low resistance. But okay, this way is or this is or L. This this is you may say that this is D1 as in the previous I have used this is D1. Okay, this is D2. These are D3. This is D4. D1 has a VZ voltage are the same. So you may say that they must be a same. Okay, so they are the same diode. These diode must be a these diode are the same, and these diode are the same. Okay, so this is VZ. Think it may be create a problem. I must write these both are equal to VZ1 and or you may say that these are I say that this is a group. You may say that these are and these diode are the VZB. This may be A may be because it's controlled of high voltage. It must may be from 5 to 5 3 voltage, and this will be B type have 3 to 3.5 volt. Okay, Uh, so what will be happen? The process will be the same. Okay. So diagram will be like with with little change. I think I must be okay. Uh, as in the case of what will be the change? The remaining thing is for parallel. The things will be the same as I have discussed the case one, but for now, there will be a change in equivalent circuit in such a way. I must draw. I think I must draw the circuit. Mm, 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 mm. Okay, fine. Here, what will be happen? The remaining thing will be same, but because the diode, but if I see that the when the voltage is less than okay for positive voltage, okay, if voltage is okay, have to discuss the remaining thing will be the same, but what will be happen D3 okay. Hmm. So now there are two type of diode. One is high volt to regulate the high voltage. One type of diode is there are two type of Zener diode. One is the ZA type of diode that will regulate high voltage and have a high voltage Zener diode, and the other are a low voltage Zener diode, and it is act like a circuit breaker for if there is a voltage is drop low than 3 voltage. How it will be at let's for this case I have to consider the for positive pass there will be a three I have to consider the three cases. Let's firstly I move it other maybe I or yeah I think I should okay, delete it. Okay. Firstly, I consider this case. Okay. If, but if, as in the previous case, if that is less than VZB, VZA, if it is less than, V ZA, if voltage is the voltage is low and less than VZB. Okay, you may say that VZA, what is the VZA? That is, sorry, a voltage is less than, because three number is, if voltage, input voltage is less than uh, VB, that is 3, and it is also less than, obviously, if that is less than the VZB, then obviously it will be also less than 5 volt, because 3 is a less number. So, and less than VZA, which is 5 volt. Then what will be happen? Uh, as I've already explained, the D1 will be act as a forward wise, as the previous case. D2 will be as behave reverse wise, and it will be act at the leakage current region. So that will be treated openly as in the previous case. But now the remaining thing will be the remain the same, but the change will be occurred when in this case, because it is less than VZB, uh, and this is a positive, so D3 will be a forward bias, but D4 will be a reverse bias, because it is less than uh, Zener diode. It is also the D3 will be this was D3 will be a forward bias. D3 will be a forward bias as D1, but D4 will be open in this case. Okay, so no current will be flow from the load resistance, and circuit will be break. So this will be the RL. Okay, and for the case of but if the but for the case of sorry, but for the case if the same case, because here we are considering the voltage V is negative. Oh no, oh sorry. But for the positive current, if but V is positive, okay, same. But if I think I don't need to mention it, because I have already that is D1, and that is a positive current. But if voltage is greater than V, as in the case of VZ, voltage is greater than VZ, B mean 5 volt. If sorry, mm, VB is greater than, okay, no, I must consider the same case if uh, but if V is if input V is less than VZD, okay, but greater than V Z A, or you may say that greater than 3 voltage V input and less than 5, then what will be happen? Because V is less than VZB, I mean, sorry, input wave is greater than, okay, I mean, like, if we here, if this is, so, if V input is greater than 3 voltage, but less than 5 volt, mean B. So, this part of, okay, sorry. I mean, this part will be the remain the same. So this means this part will be the remain the same, but because the case is the same, because V is less than VZA, so VZA, okay. So uh, VZA is in 1 minute. VZ, I think it's this is ZA. Oh, sorry, that's some mistake here. Is the P A? Okay, I think this is B because B is 3. Okay, and this is A. So B, we still, you may say that this is as less as V is, it is less here. So because the V is less, you may say that this is less. Here it is also less than 5 volt. So A part will behave like same. This is actually the um, this is actually the VA part. This will be the remain. The VA part will be the sorry. Uh, I must say not VA. This is a ZA part. This will remain the same. So there will be no change on this part. But because now the V is greater than VB, but this is ZB part. Now V is greater than ZB part. So D3 will be as because it positive D3 will be a positive D3 will be a uh, B3 will be forward wise because current part is a positive. D4 which is was a reverse wise because no voltage is greater than this uh, D4. Okay, because V is greater than VZB, mean this part. So current will pass through. That will be act as a short circuit. Okay. Okay. So for D4, D4 will be activated and current will pass through this. So in this case, the first part will be remain the same because as the VZ is V is less than uh, VZA, as the V is less than VZA, but it now it is greater than the 5, sorry, VZB, which is a 3. So this is greater than. So B diode will also it will be activated and it will allow to pass the current. So the equivalent circuit, okay, the equivalent circuit will be like you may say that mm, let me copy it. I, again, I think so. I say that now this D4 will be also, this will be a D4. So it will be also forward wise. So the remaining case will be the remain the same. Okay. Uh, Here V out will be equal to, because uh, this is here current is broken due to the green part VZB. Okay, due to this, because here is open, so no current will be passed through. So V out will be 0 at load. Okay, so here the V out will be 0. But for this case, when the voltage is between the limit 3 to 5, then V out will be equal to V in. What is the same voltage will be supplied to the input voltage. But for the case, uh, but the for the case if and the third case, if V is if V is greater than V ZA and also greater than VZB. Okay. What will be happen if mean you may say that V is greater than VZA is 5 and also greater than 3. So if in that case when V is greater than 5 volt, so then that will be the circuit will, in that case we can we have to choose this circuit. Hmm. For this case, if we compare it then there will be, because now the voltage is greater than Vz, but it is also greater than uh, uh, 3 volt VZA, also greater than 3 VZB. So remaining thing will be the same. Okay. So the VZ VZB, which is equal to 5 volt. So that this will be RL, and D1 will be remain the forward wise, D4 will be also forward wise, because there is no change in uh, this part. That part is the remain the same, because in this case VZB, because this part is related to VZA. So because it is greater than, oh no, VZB, sorry. This is greater than VZB, because if VZB, because here V is also greater than VZB. So here is also V is greater than VZB. Okay, so the case is the same. So that's why uh, the result will remain the same. So in this case, V out will be V V out will be uh, equal to VZB, which is equal to 5 volt. So this is all okay. So the same process I have discussed about earlier discussed, the same process will be for apply for the negative case too. Okay, when T2. So the difference will be that the change in the diode, the green parts, VZB part, and that will be change will be like the as I have discussed for T1. But now the D1 will be replaced with the D4. Mean when D1 in the case one in case for negative voltage, D2 D3 will act as a D4, and D4 will be act as a D3, revise vice versa. And in the case of negative, uh, I think I should mention same process as already discussed with the as already discussed, but in but in ZA region D1 DZA D1 and DZA region D1 will act D, or D1 will be vice versa D2. Okay, and in mm, in ZB, which is this is ZB region. Okay, ZB region D D3 will be replaced with D4. I mean, all the activities are D3 will replace with D4, mm, meaning meaning D3 act like D4 and D4 will act like D3. So this is all about uh, the uh, the working of diode, Zener diode as a voltage regulator. Uh, as a for AC voltage regulator and breaker at low voltage. Thank you very much. If you have any comments, any confusions, you may perform this experiment in lab. Okay. If you have any type of confusion, you may the question, and please subscribe the channel to encourage us and so that we may share uh, such kind of more videos. Thank you very much. Allah Hafiz.